Hello Algebra 1 students, it's Mr. Wilsey, and for this video I need you to take down notes on paper. It does not need to be grid paper like this. I want you to title your notes, Algebra 1, and the topic of this video is going to be factoring. Part 1. Factoring is a very immense topic, and we're going to need multiple videos in order to cover it thoroughly. So first of all, I want you to think back. So this is going to be a think back. Okay, so we'll put this in like a little thought bubble up here. We'll see how much size we need on this thought bubble. If I asked you to multiply, let's say x plus 3, a binomial, times x plus 7. So both of these are in parentheses. Now, if I ask you to multiply that, you ought to know how to do that. I taught you 3 different methods to multiply binomials. Let's do FOIL. Let's do FOIL. So first, outside, inside, last. FOIL is the quickest. FOIL means multiply the first 2 terms. So x times x is x squared. Then multiply the outside terms. X times 7 is 7x. Multiply the inside terms. 3 times x is 3x. And then 3 times 7 is 21. Okay? All of these are positive. So x squared plus 7x plus 3x plus 21. And then we would simplify x squared, combine like terms, 10x plus 21. Okay? So you ought to know how to multiply binomials. Now, factoring, as I've mentioned in previous videos, is the opposite of multiplying. So, in a multiplying problem, you start with something that looks like this, and you wind up with something that looks like this. But if I asked you to factor something that looks like this, x squared plus 10x plus 21, this means that I want your final answer to look like this, x plus 3 times x plus 7. Okay? And this is what you would box. Okay? So when you multiply, start with something that looks like this, wind up with that. When you factor, start with that, wind up with that. Now, when the directions are factor an expression that looks like this, the first thing that you should immediately write down on the next line is equals, in parentheses, something. Okay? There's going to be 4 terms in all. There's going to be a term here, term here, term here, term here. Now, this is a particularly nice example because there is an invisible, can't read that, invisible 1 multiplying the x squared. Okay? So if you have an invisible 1 multiplying the x squared, and only if you have an invisible 1 there, you can immediately know that there's going to be an x here and an x here. There's not going to be any number out front. There's not going to be any number out front. Okay? So really, factoring comes down to the question of what number do I stick here and what number do I stick here. Okay? It turns out that the numbers are going to be 3 and 7 in this particular problem. But how in the world would we find 3 and 7 if we didn't know anything else? Well, let's see how we found the 10 and the 21 up here when we multiplied. Let's think back to our think back. The 10. How did we get the 10? Well, 7 plus 3. 7 plus 3 gave our 10, which multiplies the x term. Now, how in the world did we find the 21? Well, we found the 21 by using FOIL. Remember? First, outside, inside, last. The 21 was 3 times 7. We're going to flip that around. 7 times 3. So we added the two numbers here to get 10, and we multiplied these numbers to get our 21. And that's exactly how we're going to find out what numbers we stick in these blanks here. Okay? So let me write this out in a complete sentence, and I want you to write this out as well. What two numbers add up to give 10, which is the middle number, it's the number multiplying the x, and the same two numbers multiply to give 21. As soon as you can answer that question, you plug the numbers into these blanks and you have factored. That's all there is to it. Now, in order to help you answer this question, this is the easiest thing that I've come up with. Let's think about the 21 first of all. 21. What I want you to do is think of factor pairs. Factor pairs of 21. Okay? Let's think of pairs of numbers that multiply to equal 21. Okay? Now, I'm starting out this as if I was drawing a factored tree of 21, but I'm not drawing a factored tree exactly. Okay? You'll see the difference. So what two numbers multiply to equal 21? Well, 1 and 21 multiply to equal 21. What else? 2, no, not 2. How about 3? 3 and 7 multiply to equal 21. And while we're at it, we might as well say that -1 and -21, don't these two multiply to equal positive 21? And -3 and -7 also multiply to equal a positive 21? Okay? So what I've done here is I've listed all the pairs of numbers that multiply to equal 21. Now, I'm going to go through each pair and I'm going to ask, what do these pairs add up to? So 1 plus 21 is equal to 22. 3 plus 7 equals 10. -1 plus a -21 is equal to -22. And -3 plus a -7 equals -10. Okay, so all I did there was add these guys. Now, remember our question. What two numbers multiply to give 21? Well, all of these are candidates, but only one of these factor pairs will add up to give 10, and it's right here. Only 3 and 7 add up to give 10 and multiply to give 21. Therefore, the two numbers that I stick in these blanks here are a positive 3 and a positive 7, which is exactly what we started with, of course. Alright, now let's take a look at our first real example, okay? Because we already knew what the answer was going to be up here. Now let's try an example in which we don't know what the final answer is going to be. So example number 1. Factor x squared plus 11x plus 18. Okay? Now again, immediately you should know to write down equals, in parentheses, what? Okay? The result of factoring that expression will be two binomials multiplied together. Now again, because I have an invisible one multiplying the x squared, I know that there's going to be an x here and an x here. So all I need to do is figure out what goes here in this blank and what goes here in that blank. Now, remember, in order to figure out those two numbers, we need to ask ourselves this question up here, except the numbers are different. Okay? in this case, we're going to ask ourselves, what two numbers add up to give the middle number, the number multiplying the x, so what two numbers add up to give 11, and multiply to give the last number, 18, the constant. Now to help now to help answer that question, remember what we did up here. We made a list of the factor pairs of the last number. So in this case, let's make up a list of factor pairs of 18. So I'm going to write down 18. I'm going to have two lines coming from it, and then I'm going to list pairs of numbers that multiply to equal 18. Well, first thing I can think of is 1 and 18. Now, if 1 and 18 work, negative 1 and negative 18 also work. How about 2? 2 times what equals 18? 9. If that works, then so does this. What else? How about 3 and 6? Is that right? 3 and 6 and negative 3 and negative 6? How about 4? 4 times anything? No. 4 is not a factor of 18. 5 is not. 6 is. But then we get back to 3 here. Okay? So this factor pair is the same exact thing as that factor pair. So as soon as I start recycling numbers, I can just stop listing out the factor pairs. Okay? So these are all of the possible factor pairs of 18. Now, just like we did up here, we found the numbers that multiply to equal 18. Now let's see which ones of these add up to give 11. Let's see, 1 plus 18 is 19. Negative 1 plus negative 18 is negative 19. 2 plus 9 is 11. Oh, wait, I'm done, right? I found a factor pair of 18 that adds up to 11, which is the middle number. So I'm done, right? I found my 2, I found my 9. So x plus 2 times x plus 9. That works, okay? Now, if you want, you can always check your answer. The way to check is to multiply this expression back out. So x plus 2 times x plus 9. Let's see, I'm going to use FOIL. First, outside, inside, last. So x squared plus 9x plus 2x plus 2 times 9 is 18, and then 9 plus 2 is 11x. There we go. It works. Check. Okay? So this right here is the final answer. This is the factored form of x squared plus 11x plus 18. Okay? So that's all there is to it, to factoring expressions that have an invisible 1 multiplying the x squared. So now let's look at example number 2. How about this? How about k squared plus 3k minus 40. We want to factor that. Okay? Now first step, write down equal sign, parentheses, multiply together. Bam. Now, there's an invisible 1 multiplying the squared term, so I know that I'm going to have a k and a k. No numbers multiplying these, except for invisible 1s. Now, the question, again, boils down to what goes here, what goes here. So the question we're going to ask is, what two numbers multiply to equal negative 40? Sorry, I'm going in the opposite order that I did in the other ones, but that's all right. What two numbers multiply to equal negative 40 and add up to equal 3? The way that we're going to find that is make a list of factor pairs of negative 40. Factor pairs of negative 40. let's see, 1 times negative 40 would work. If 1 times negative 40 works, then what if we just switch the signs? What if negative 1 times positive 40? That would also multiply to equal negative 40. What else? Let's just go up. Let's start at 1 and then go up 1, 2, 3, 4, 5, 6, 7, and so on, and see what numbers work. So 1 to 2. 2 times what equals negative 40? Well, negative 20. Then negative 2 times positive 20 will also work. How about 3? Is 3 a factor of negative 40? No, it's not. But 4 is. 4 times negative 10. Negative 4 times positive 10. How about 5? Yeah, 5 will work. 5 times negative 8. And then negative 5 times positive 8. Will 6 work? No. 7, 8. As soon as I get back to 8, 8 times negative 5 will work. But look at that. I've already written that down right up here. So I'm done. I am done. Because I've started recycling my numbers. Now, which ones of these factor pairs add up to equal 3? Let's see. These don't. What about here? 5 plus a negative 8. Oh no, that equals negative 3. But negative 5 plus positive 8, that equals positive 3. So that's it. It looks like our very last factor pair that we found will work. Negative 5 plus 8 gives 3. That means that the special numbers that I put in here and here are going to be negative 5 and positive 8. Ta-da! We are done. Okay, with that problem at least. So box that guy. Now let's take a look at a third example. How about factor r squared minus 13r plus 42. Okay? Now I'm not going to write out everything. What I will write out is equals what? Okay? Invisible 1, multiplying the r squared, so there's going to be an r here and an r here. What goes here? What goes here? Now, let me tell you something interesting. You do not have to do all of this work here. You do not have to. The only reason we had all of this work here is to find the special pair of numbers that multiply to give the last term and add up to give the middle number, the middle number there. I don't care how you find the magic pair of numbers. All I care about is that you do find them and you stick them into those blanks. So if you look at this problem here and you ask yourself, let's see, what two numbers multiply to equal 42 and add to equal negative 13? And if it just pops into your head that, oh, negative 7 times negative 6, let's see, these two numbers multiply to equal positive 42 and they add up to equal negative 13. If you can do that in your head, you are done. You are done. You do not need to show all of this work. The only reason that I had you do this was because this will always find the magic pair of numbers. If you list out every single factor pair and add them all up, you will always find the magic pair. Now, just in case you didn't see that as quickly as I did, and the only reason I saw it quickly is because I know what the answer is, let's go through the whole machinery. So 42. What two numbers multiply to equal 42? Let's see, 1 and 42, negative 1 and negative 42, 2 and 21, negative 2 and negative 21, 3? Yeah, 3 and what? 3 and 18? Is that right? No, 3 times what? 3 times what? Now, in this case, I'm having trouble thinking of? What number times 3 will give 42? I know that 42 is divisible by 3 because of the divisibility rules, right? The sum of the digits is 6, which is divisible by 3. I don't know if you remember that from middle school or not. But if I'm struggling to think of what number times 3 gives 42, all you have to do is take 42, divide by 3. What do you get? 14. So 3 times 14 would give 42. So negative 3 times negative 14 would also work. How about 4? Does 4 work? No, 4 does not work because 40 is divisible by 4, and then you'd have to get 44 to be the next one. How about 5? 5 doesn't work. 6? Yeah, 6 works. 6 times 7, and negative 6 times negative 7. Okay? Now, which ones of these factor pairs add up to negative 13? Well, this is 43, this is negative 43, this is 23, this is negative 23, and so on, This is 13, this is negative 13. Okay? So this right here is the answer. Negative 6 and negative 7. Notice, of course, that it doesn't matter what order you put these in. Okay? So I think that is it with factoring.